Once you know those two facts, then you're going to be able to differentiate functions like this. If we have y is equal to sine of x plus 4 times e to the 0.5x power, then the derivative of this equation y with respect to x, derivative of sine is cosine, and then we'll have 4 times the derivative of e to the 0.5x power, which would be 0.5 e to the 0.5x, and then simplified, this is cosine of x plus 2 e to the 0.5x power. You can also use the product rule and the quotient rule as necessary. So if we're going to differentiate that function, thinking about the quotient rule first, bottom function times the derivative of the top. Now to differentiate the top, we have to use the product rule. First times derivative of the second plus the derivative of the first times the second. Alright, so there's the bottom function times the derivative of the top minus the top function times the derivative of the bottom, all divided by the bottom function squared. At this point you have found the derivative function. It's just a matter of simplifying that algebraically. So we would have x cosine x plus x cosine squared x plus sine of x plus sine of x cosine of x plus x sine squared x all over 1 plus cosine of x squared. Now I notice that those two terms have a common factor of x, and if I factored out the x, I would be left with cosine squared x plus sine squared x, which is 1. So I'm going to shift things around. And out of those two terms that are highlighted, I'm going to factor out the x and look at cosine squared x plus sine squared x, and then the other two terms I'm just going to bring straight down, plus sine of x plus sine of x cosine x. Okay, x cosine x plus x plus sine of x plus the sine of x times the cosine of x and now what I notice is that if I look at those first two terms, there's a common factor of x there. And if I look at these two terms, the last two terms, there's a common factor of sine of x there. So factoring the common factor out of each of those groups, x comes out and leaves cosine of x plus 1. Sine of x comes out and leaves 1 plus the cosine of x. And now the common factor is 1 plus cosine of x. So I pull that out. And reducing, we'll be left with x plus the sine of x over 1 plus the cosine of x. Okay, so that example reviewed product rule, quotient rule, and derivatives of sines and cosines. Alright, now we know the derivative of sine and we know the derivative of cosine. Those are actually the kind of like the basics, since each of the other 6 trig functions can all be written in terms of sine and cosine. Then once you know derivatives for sine and cosines, you can find derivatives for any of the other trig functions. We'll start with looking at the derivative of tangent of x. You have to start by rewriting tangent of x as sine over cosine. Then apply the quotient rule. Bottom function times the derivative of the top function minus the derivative of the top. No, backwards, sorry. I'm wrong. Erase, erase. Okay, bottom times derivative of top minus the derivative of the bottom times the top, all divided by the bottom function squared. So cleaning that up, you've got cosine squared x plus sine squared x on the top, and you have cosine squared x in the denominator. So 1 over cosine squared x is the same thing as secant squared x. So we have just proven that the derivative of the tangent function is the secant squared. Now the other 3 derivatives for cotangent, secant, and cosecant are left for you to derive. They are part of the homework assignment in your textbook that I've assigned. But I do want to kind of, here are your derivatives for all 6 trig functions. You have to know them. You just have to memorize them. And what I would recommend that you do, there are some patterns here that kind of help make and memorize these things a little bit easier. Notice all of these on the left. I'll give you a hint. If you can make yourself memorize those 3 and then think about the patterns and how these things work, then you'll know all 6. Sine and cosine are what we refer to as co-functions. Tangent and cotangent are co-functions. Secant and cosecant are co-functions. the derivative of sine is cosine. You memorize that. The derivative of the cofunction, you'll notice each of these is negative, and it's the negative cofunction. So if you know the derivative of sine is cosine, then the derivative of cosine is the opposite of the cofunction for cosine. If you know the derivative of tangent of x is secant squared, then the derivative for cotangent x is the negative cofunction squared. So it's negative cosecant squared. If you know the derivative for secant of x, oops, that's wrong. That's secant of x times tangent of x. That will make a difference. There we go. If you know the correct derivative for secant of x, then you're going to know the derivative for cosecant because it's the cofunction. Alright, whoop, come back. There we go. If we have this equation, y is equal to cosecant theta squared, cosecant squared theta subtract 1, and we need to find the derivative of that. First of all, there we go. First of all, you're going to have to think of cosecant squared as cosecant of theta times cosecant of theta. We don't yet know how to find a derivative of a power of a function. That's a composite function. But if we rewrite it as a product, then we can use the product rule. So dy over d theta, the independent variable is theta this time. The derivative, let's see, product rule, first times the derivative of the second plus the derivative of the first times the second. Okay, and then of course the derivative of -1 is 0, so plus 0 out there at the end. Then if you neaten that up just a little bit, you're looking at negative cosecant squared theta times cotangent theta minus cosecant squared theta times cotangent theta, which is -2 cosecant squared theta times cotangent theta. Okay, next example. Our equation is y equals tangent of x, but we want to find the second derivative. Well, we know the first derivative is secant squared x. That's one of the ones that we've memorized. So rewriting that as a product secant of x, or theta times secant of theta, then we can differentiate that function to get the second derivative using the product rule. Well, I changed variables, didn't I? That's not good. Make those x's. It's just been one of those days. Okay, taking the derivative with respect to x then of secant x times secant x. First factor times the second derivative of the second factor plus the derivative of the first times the second. Clean it up a little bit. Secant squared x tangent x is in both terms, so we can combine like terms.